After learning how to find shared elements using intersection, let's now explore how to find what makes one set different from another. This is called the difference of sets. The difference operation helps us identify elements that are present in one set but not in the other. It helps highlight what's unique to a specific group. The difference of sets A and B is written as a minus B. This represents all elements that are in A, but not in B. Let's take an example. Set A is 1, 2, 3, 4. Set B is 3, 4, 5. Close then a minus B is 1, 2, because 1 and 2 are in A, but not in B. On the other hand, B minus A is 5, as 5 is in B but not in A. A very important rule, order matters in set difference. A minus B is not the same as B minus A. In our earlier example, a minus B is equal to set 1, to B minus A is equal to 5. These two results are completely different. Always pay attention to which set comes first in the expression. Let's understand this visually with a Venn diagram. Draw two overlapping circles for sets A and B. The part of A that does not overlap with B is shaded. This region is A minus B. It excludes any element that is shared with B. Similarly, B minus A would be the portion of B that is outside the overlap. Let's say set A represents students who opted for mathematics, and set B represents students who opted for economics. A minus B gives you all students who chose only mathematics, not economics. B minus A gives you those who chose only economics, not mathematics. This operation is extremely useful in data segregation, exclusion filtering, and decision making. Set difference shows what's unique to one set. A minus B drags elements in A but not in B. B minus A elements in B but not in A. Order is important. The results change depending on direction, visualized in Venn diagrams by shading the non-overlapping part. Up next, we'll explore the complement of a set, which compares a set to the entire universal set.